Alright, okay YouTube. It's been quite a while since I put a video on. Um, Thought I'd do that today. It's a little awkward to say this, but you know, I don't like to put a video on YouTube if I don't have a fix for something, or if I can't show you an improvement for something. So I'm kind of going out on a limb on this, but just because I don't have a fix for it just yet, and it's certainly not an improving thing, I think it can still be helpful. So I'm still going to do this video. Based on sometimes when it comes to electronics, not knowing what the problem is can be just as almost as helpful as knowing what the fix is for the problem, if that makes any sense. Process of elimination sometimes. So from that aspect, I'm going to go ahead and do this video. And I just want to thank everybody that puts videos on YouTube for the time that they spend, because it takes a ridiculous amount of time editing videos and covering up mistakes and things like that. First of all, when it comes to radios, some people dream about $5,000 ICOMs, and some people dream about things that are slightly less expensive, and I kind of fall into that case. So my hopes were to have a Navaho trc-457 here to use, and I don't know if that seems kind of humorous in comparison, but maybe that will show you something about my character or my background. I don't know. That's been a royal pain in the backside, to say the least. I have about 36 hours of time into this. I have not slept for many, many days, and I'm being completely honest with that. So I'm going to have to really try to focus here to make sure that I don't throw out some words that I don't mean to throw out, because sometimes that happens when you haven't slept for a while. You mean to say amps and you say volts and etc. You know, hey, I'm an honest person. You never know what I'm going to say on my videos. I like to keep things interesting, so I hope. So, when I opened this unit, I thought to myself, is this going to be a repeat of my last buy? And is it going to be a Trojan horse? And it's in phenomenal shape. I mean, it's really quite beautiful. My lighting is very, very poor. I can't see what the camera sees, forgive me. It's in very, very beautiful shape, which raises the stakes even higher. And kind of a laughable situation here is you might notice in the video here there's a couple new capacitors in here, and you might be thinking, well, why in the world would you put new capacitors in? And this is kind of an end result, because you'll know in the end here the capacitors weren't to fix. So why would you put new capacitors in this unit if you didn't expect that to fix the unit? Well, I look at things a little bit differently. And the reason I did that today was to give myself a mental break from this, because I'm absolutely overloaded with it, to the point in which I can't keep numbers straight in my head anymore with these transistors. So I did that to give myself a mental break, and also to raise the stakes even higher, because I've never given up on anything, and I've never quit on anything. But by me sticking some high dollar caps in here, from my financial aspect, raises the bar to fix it. So I'm hoping that makes sense to you, the logic behind that. and the crazy things that I do for the reasons that I do it. So anyway, this has an unlocked PLL, and it is essentially a loop, a semi-closed loop, and it's a pain in the backside, I'll tell you that. It's kind of analogous to the feedback on an op-amp, but not really, because there's much more things involved in it. So it is kind of a servo loop. It's just a much bigger servo loop, where the ability to manipulate it, from my experience, isn't as great as compared to comparing this whole big area to an operational amplifier. Because I know them like the back of my hand, and I could easily go in and manipulate an op amp to do anything that I want to do. But this I just can't seem to manipulate into doing anything. So with that analogy, it is unlocked. And when it's unlocked, you have no transmit, no receive, no nothing. Basically, you're probably not even receiving static from outer space. And the telltale sign that this is unlocked will come back to I went to the library and I made some very gigantic sheets on ledger paper, because fighting a battle like this facilitates having schematics, especially schematics you can read. And while all these lines that lead to places that you can't see causes problems, at least I can see this area of it. So it's not completely cut and dry, but you know what? We'll take what we can get at this point. So the telltale sign is TR32, which is sitting out here in yonder land, is turning this guy on and pulling our 8.8 volt rail down, coming off the power supply. And when it does that, that indicates that the PLL is locked out. There's actually two other transistors that I'll get to in a minute here that are also turned on, but this is a stop transistor. So if you have a Navaho here, just go to the collector of this 2SC945, and you'll probably see 7/10 of a volt here, because this transistor would be saturated if it's locked out. Are there any other instances that it could be locked out for other than maybe what I have? Yes. But regardless, if it's not transmitting and receiving, it's going to be locked out, and this guy's going to be on. From a design aspect, I'll just tell you real quick, this makes absolutely no sense to me why this was done. It really truly doesn't. Why they decided to just pull this line low seems like a poor way to shut things off, but that's what they did. So when this guy turns on, he's going to suck this voltage down a small amount, and you'll probably see the voltage here on pin 4 or on this imaginary 4 drop down a little bit lower, but it'll probably still be enough to keep this voltage regulator, the 7805, pretty happy at pretty close to 5 volts. So it's kind of pointless, this switching transistor, from that aspect, because it'll keep this active. You know, you might see a couple hundred millivolts drop here, but that's going to be about it, if even that. But this line here is definitely going to suck to 0.7 volts. So let me just make sure that my camera is seeing what I see. I'm sorry, I should have probably had the schematic up there for you to be able to get a better visual on what I was talking about. But there's our TR29 switch. So right there's TR29's location, and I pulled him out, It didn't do any good to pull him out because it didn't give me any more of an ability to troubleshoot what's wrong because of this crazy loop. But that's where he's at. Now, a little bit of the background information here is this, and I think I started to touch on this and I got sidetracked. I bought this from somewhere that I know better to buy electronics from, and when I got it open, I saw everything was very beautiful on the inside. And I thought to myself, you know what, Mike, this is almost too good to be true. It looks like this unit has never been touched, and immediately then I saw all the cans were marked, and I thought, you know, catastrophic thoughts, Mike. Some yahoo has come in here and turned every single one of these slugs. You know, that's the way I think. And the reason I think that way is because I have that stuff happen to me. So my heart immediately sank. But I'm not 100% sure that was the case, that somebody had come in and turned every single one of these slugs, long story short. So I was really, really happy when I saw that I didn't have a hacked up PLL. I didn't have any obvious signs. Well, actually, I had absolutely no signs that some hack shop had come in here and tried to make this radio do things it wasn't intended to do. And with just the top cover off here, I was feeling pretty good about it. And then all of a sudden, and this comes down to, you got to be a great detective. I say this in all my videos. There's two things I say the most. I'm a very small fish in the pond, and you got to be a great detective. And I don't know why it is, but I can't emphasize those things enough. So when I got up here, I saw that there was not a unit in PLL in it. And I thought, oh my word, you gotta be joking me. There was a GE1198 in this, and I thought, man, you are in a whole load of trouble here. No other signs anywhere. Now, when I bought this, the cover, the bottom cover, was not shot in the photo. And don't ever buy anything unless you get a total shoot from all angles and look for missing screws. I'm just going to tell you that just in case you don't know that. Look for missing screws. If you see missing screws, don't go there, because that means something. That means that somebody was in that radio and didn't have a good code of ethics. Because how can you care good enough to repair something if you didn't care good enough to put the screws back in the unit? That is how I view things. So when I went down to the bottom here, saw there were screws off and the cover was just kind of hanging, I thought, you know what, I'm in a boatload of trouble. And I was absolutely right. When I pulled the cover here, both covers were missing. Here on the PLL, actually just cutting short of the PLL. There's a tie point, there was a tie point, that was ripped off. Whoever had pulled the cover, I have no idea. They truly didn't really care about anything, just kind of ripped it off. There's 4 tie points, not that it matters, but just trying to see where they were here. Boom, 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 boom. I don't know if I got them. Anyway, doesn't matter. So I rebust the paths, and I said, let the games begin. So with the locked out condition, and actually let me back up here just a minute. There was 2 transistors, and this was kind of the straw that broke the camel's back. There was 2 transistors klooched across the back side of the board here that kind of set me mentally on fire. And they looked like they had been soldered with a match. Some of the leads weren't connected, and I came to find out he probably didn't have them connected for a reason. But the transistors that we're setting here, and I don't want to get particular to my unit, otherwise this video won't suit you. Because obviously your situation, if you're watching this, is different than mine. But the transistors that we're setting there were TR35 and TR32 sitting right here, which were contact cemented up against the VCO here. So I came to the conclusion the guy who was trying to fix this definitely knew what he was doing. He knew where to look, but he couldn't complete it. And apparently, from all the signs I saw, said, you know what, the heck with this thing, it's not worth it. But you know what, it's worth it to me. I will do whatever it takes to get this radio working, no matter how much sleep I go without. So I got 36 hours into this. I knew it was not the PLL. I was 99.9% certain. But I went out on a limb and replaced the PLL back to the Uniden 858. Of course, it made no difference whatsoever. So let me just take a pause here a second and try to get myself focused on where I'm going with this video here. So I just had to get my bearing here and make sure I'm putting my focus on giving information that could be helpful to somebody, because I don't want to get caught up and sidetracked in my own situation with what I have here. So I gave you the first piece, or the first sign, and that is this guy being turned on. But there's some redundancy in that. And if you can bear with my ledger size paper here, there's actually two other transistors that are going to be turned on as well. TR33, which I kludged in here, and TR32, which is actually called the outer lock detector. So it actually flips on two other transistors. Flips this guy on and flips that guy on. So the TR29 is up there that I gave you. TR33 is right here beside that 33 ohm resistor, and TR32 is right here beside that VCO. So this guy that had went ahead and tried to fix this was definitely on the path, because this is the one transistor that was located to the back of the unit. So there's three transistors that are going to have this guy locked out. Now this one here, TR29, that I told you about, disintegrates this 8.8 volt source. Now TR33 actually, from what I see, shuts down the mixer. It shuts down the transmit mixer. I'm not sure if I have that schematic here or not. I don't want to spend a load of time on this. Oh, let me just see if I have it. I don't think I do on this pile right here, but anyway, I can't show you where the mixer is, but here's that line I was talking about. That looks to shut down FET1 receive mixer and FET7, which is a transmit mixer. Now, I'm referencing this against another video that I saw on YouTube, where a gentleman had this radio and he fixed this problem. He did something that fixed his problem anyway, and his problem was identical to mine in every aspect. However, that did not work on my unit. So what he did, and I'm speculating a little bit, but what I'm ascertaining that he did was he went to the VCO can undoubtedly, probably L17, and retuned L17 and manipulated this VCO into working. He probably also undoubtedly adjusted L16 at some point in time, but I didn't do that on my unit here. And also from what I'm ascertaining is that when he did this, he was able to get pin 5 on the VCO to go to the voltage that it's supposed to be at. Mine does not. His voltage, and I'm referencing against a specific video, I think the gentleman said he had 4.3 volts here, and after he went through and adjusted that stuff and adjusted it down to 2 volts, he got the PLL to lock. Mine does not come down there. Mine actually sets at 4.788 volts and does not move for nothing, not even love or money. So my VCO is not in limits. Now, one other interesting note is FET 4, which is sitting right down here, is the PLL Mixer. It is not working. And from what I ascertained from this, FET 4 is fed from this double can, which is L24, which is right here, which is fed from the tripler back to the oscillators. Now, I have verified every single power supply voltage in this unit, undoubtedly, to be there. Right down to the cans themselves. I have physically checked the voltage on every tap on every pertinent can to make sure that it didn't disappear, because there's a lot of 100 ohm dropping resistors on this board. So I physically probed the board and not just trusted that the power supply sent the voltage there. So there's no voltage issue anywhere. And the reason I brought up the voltage issue is because of this. What I saw on this PLL mixer doesn't quite make sense to me. On gate 1 I have 160 millivolts, and on gate 2 I have 80 millivolts. It appears to me that those signals are not large enough to wig-wag this FET. This FET is known to be good. I pulled it, physically checked it 2 occasions, and it's good. However, there is absolutely no signal on the drain of this FET. I have isolated that there is nothing on this line that's causing a low impedance condition that could be manipulating this and dragging this to nothing. Everything throughout here is totally 100% fine. I've even pulled this AC grounding capacitor or gain resistor or gain cap, whatever you want to call it, sets the AC gain. Even pulled it and checked it, and it was pretty much spot on at 041. So this FET should be wig-wagging. So the only conceivable reason is this is not enough signal to wig-wag it. That's the only conclusion I can come to. And of course that all leads back right in to the divider, which is a big vicious loop. I just want to refocus myself here a minute because I don't want this video to take forever, because I want to give things that are helpful and make sure that I don't miss anything. So what this gentleman had adjusted, I'm working under the assumption, was L17. L17 is right here. It was factory sealed. There's no doubt in my mind this can was never touched. This can does not manipulate this, we'll call it a control voltage, to the VCO on my unit. So that's L17, L24. So to get to my point, I will tell you everything that it is not, because I can't give you the fix. So I'll just go through this as quickly as possible, without any explanation really. TR29 is not the problem. TR33 is not the problem. TR32 is not the problem. TR35 is not the problem. TR31 and 30 are not the problems. All have been pulled 2 times over and beta checked. These tantalums right here are not the problem. These tantalums were replaced because my cap checker pulled a Casper the Ghost on me and tried to trick me into thinking that these tantalums were bad. And then after I replaced them, I said, you know what, I don't believe that cap checker. I checked it again a couple days later, and the cap checker says, yeah, they're good. And I said, yeah, I knew that. And the reason I know that is because tantalums in here, in this high impedance area, typically don't go bad. A lot of times I see tantalums get a bad rap because people just skim across the surface, and they like to blame tantalums. And tantalums do go bad, and if they go bad, they almost always short. But 9 times out of 10, if not 9.9 times out of 10, if that tantalum shorted, it's because it's a tantalum on a low impedance line. So tantalums in here would never fail. So I just wanted to tell you why they were replaced, if you just happen to know that normally they're blue ones. This card edge connector is not the problem. People like to blame these connectors for problems when they're not the problem. It's not the problem. People also like to blame these for problems. It's not the problem. Nothing on this channel selector board is the problem. I've checked it a million times, and that PLL is chip is getting exactly the binary input it's supposed to have in all cases. Obviously this unit and chip is not the problem because it was replaced twice. To sum it up, let me just make sure I can go this far and say this accurately. And I'm pretty sure I can, with a stipulation. Nothing in this whole entire area is the problem unless it is a oscillator. That I can accurately say. So there are no bad caps, there are no bad transistors, there are no resistors without power. And I think that pretty much covers all the bases. So let me just make sure. Voltage regulator, not the problem. Everything has been pulled and checked. FET7 is a transmit mixer. It is not the problem. It has been pulled and checked twice. It's a perfect dual gate MOSFET. So there you go. I wanted to try to sum it up as quickly as I could. I hope this helps you in some way. If you have a unit identical to mine with the same problem, I think this will help you hugely, because I've just ruled out like 90% of everything that it could possibly be. You know, there we are, have at it. So hey, I appreciate you watching my videos very much. Have yourself a wonderful day.